The Refraction Lab. Our aim? To find the refractive index of perspex. Materials needed are a semicircular perspex block, a sheet of paper, a ray box, 12 volts, a single slit, and a power box. It is crucial that the power box is set at 12 volts only, otherwise you will most likely break the ray box. Take your semicircular block and trace it onto your blank sheet of paper. Make sure to leave an adequate amount of space around the block. After tracing your block, draw its normal, which is perpendicular to the object's refractive boundary, in a dotted line. Plug the ray box into the power box, which should too be plugged into a main power source. Turn on the main power switch and the power box flip switch. Put the single slit into the ray box. Turn off the room lights. The semicircular block should be placed right on top of its trace. Point the ray of light from the ray box onto the normal at the refractive boundary at all times. The choice of change in angle is yours. Most important is that your ray of light doesn't stray from the normal at the refractive boundary. Two important things to know. The ray of light coming directly from the source to the refractive boundary is your angle of incidence, in other words, theta 1. The bended ray coming out through the other side of the medium is the angle of refraction, theta 2. Take your pencil and mark an X on the angle of incidence and another X on the angle of refraction. Record each measure, degree, of the angle of incidence theta 1 and the angle of refraction theta 2. Find the sine of the angle of incidence and the sine of the angle of refraction in your calculator, and record each measure. Repeat this procedure 10 times for at least 10 to 11 sets of data. Once you're done, your diagram should look something like this. Put all of your data in a neat table. These are our sine calculations from our experiment. Graph your data on Excel and add a line of best fit. Have your equations shown on the graph. Our slope is about 1.37, which is relatively close to the absolute refractive index for perspex, 1.456. Reasons for the slight error in our slope could be a human error because we marked the angles of incidence and the angles of refraction by hand. We also have an outlier in our results, which affected the slope of our graph. But because our errors were human-made, there's not much we could have done to prevent it. One thing we could do for the future is to improve personal cautiousness. In conclusion, we found that Snell's law is right. The ratio of the angle of incidence and the angle of refraction is a constant. Although it would have been more true if our experiment had been a little more accurate, it still supports this theory as most of our ratios came out the same, and our general ratio was close to its actual refractive index, with only a difference of 0.09.